The solar chromosphere is a dense layer of the solar atmosphere, which is directly behind the photosphere. The chromosphere is quite problematic to observe due to its close proximity to the photosphere. It is best seen when the moon covers the photosphere, i.e., during solar eclipses. Solar prominences are huge bursts of hydrogen resembling glowing long fibers. Protuberances rise to enormous distances, reaching the diameter of the Sun, moving at about 300 kilometers per second, and their temperature reaches 10,000 degrees. The central part of the Sun, with a radius of about 150 to 175,000 kilometers, where thermonuclear reactions take place, is called the solar core. The density of matter in the core is about 150,000 kilograms per cubic meter, and the temperature at the center of the core is over 14 million Kelvin. The core is the only place on the Sun in which energy and heat are derived from thermonuclear reaction. The rest of the star is heated by this energy. All of the energy of the nucleus flows sequentially through the layers, all the way to the photosphere, from which it is emitted in the form of sunlight and kinetic energy. A thin layer, the photosphere of the Sun, is located directly behind the convective zone and represents the real solar surface, visible from the Earth. For the first time, the granules on the photosphere were photographed by the Frenchman Janssen in 1885. The average granule has a size of 1,000 kilometers, moves at a speed of 1 kilometer per second and exists for about 15 minutes. Dark formations on the photosphere can be observed in the equatorial part, and then they shift. The strongest magnetic fields are a hallmark of such spots, and the dark color is obtained due to the lower temperature relative to the surrounding photosphere. Above the nucleus, at distances of about 0.2 to 0.25 to 0.7 of the solar radius from its center, there is a radiant transfer zone. In this zone, energy transfer takes place mainly by emission and absorption of photons. Closer to the surface of the Sun, the temperature and density of matter are no longer sufficient for complete energy transfer by over-radiation. Vortex mixing of plasma occurs. Energy transfer to the surface is made mainly by motions of the matter itself. On the one hand, the matter of the photosphere, cooling at the surface, plunges deep into the convective zone. On the other hand, the matter in the lower part receives radiation from the radiative transfer zone and rises upward, both processes occurring at a significant rate. This mode of energy transfer is called convection, and the subsurface layer of the Sun, approximately 200,000 kilometers thick, where it occurs, is called the convective zone. As we approach the surface, the temperature drops to an average of 5800 Kelvin and the gas density to less than 1/1000th of Earth's air density.